All right, let's talk about Amazon EKS. If you're prepping for the AWS Solution Architect exam, you know Kubernetes is a beast. So, in this explainer, we're going to cut through the noise and focus on the exact architectural pieces you need to nail to pass that exam.
Here's the game plan. We'll kick off with what EKS actually is and why you'd even use it. Then we'll hit the big three for any architect: security, resilience, and performance. And we'll wrap it all up with a rapid-fire review of the key things you've got to remember for test day. Ready? Let's get into it. So before we can really get why EKS is so great, we have to talk about the problem it's designed to solve. And that problem is that running a Kubernetes control plane all by yourself is, well, it's a nightmare. Seriously, just take a second and think about it. You're going to roll your own Kubernetes control plane? You sure about that? Because you're signing up for a whole lot of work. You'd be on the hook for, well, everything. All the patching, all the scaling, making sure it's highly available so it doesn't just fall over at 3 a.m. Not to mention all the tricky integrations. It is a massive, massive operational headache.
And that is where EKS comes in to save the day. It's Amazon's managed service that just takes that whole control plane problem off your plate. AWS handles the patching, the scaling, the high availability, all of it, so you can focus on what you actually care about, building and running your apps. If you remember one thing for the exam, it's this. With EKS, AWS manages the control plane. You don't.
Okay, let's pivot to our first big pillar, and you can argue it's the most important one: security. As a solution architect, you have to realize that securing EKS isn't just one checkbox. It's about thinking in layers, securing every single part of the stack. You've got to think about IAM for who can do what. You need to secure the pods themselves. You have to lock down the network. You have to protect the actual servers, the nodes. And, of course, you have to handle all your secrets and encryption. It's a whole strategy, not just one fix. Now, all of those are super important, but if there is one security concept you need to know cold for the exam, it is this one. How do you give a single pod running inside EKS very specific, least privileged permissions to talk to something like an S3 bucket or a DynamoDB table? The magic answer is IAM Roles for service accounts, or as you'll hear it, IRSA. Now, here's how it works, and it's pretty slick. Instead of stuffing secret keys inside your container, which is a huge security no-no, the pod gets a special Kubernetes service account. You link that account to a specific IAM role. Then the AWS tools inside your container do this clever handshake to trade a token for temporary, short-lived AWS credentials. It's beautiful, it's secure, and it's the right way to do it. Okay, shifting to network security. The best practice, the philosophy you should start with, is zero trust. What does that mean? It means you start with a default deny policy. Out of the box, no pod can talk to any other pod. Nothing. Then you very deliberately poke holes in that wall, only allowing the specific traffic you need. And here's another awesome tool for that: security groups for pods. See, in the old days, you'd put a security group on the whole server, and every pod on it got the same rules. Kind of clumsy. But now you can attach an AWS security group directly to a pod. As you can see right here, this gives you surgical control, like saying only these specific application pods are allowed to talk to my RDS database. It's incredibly powerful. All right, security's covered. Now let's make our applications tough as nails. Let's talk about resilience. As an architect, your job is to build things that don't break, or at least can handle breaking. EKS gives you all the Lego bricks, but you have to know how to put them together. Let's start with rule number 1. The first rule of Kubernetes Club is you do not run a single pod by itself in production, ever. You always use something called a deployment. Why? Because the deployment's whole job, as this quote says, is to be a babysitter. It makes sure you always have the right number of pods running. If one dies, boom, the deployment controller spins up a new one instantly. It's self-healing. So what about disruptions that you cause, like when you need to upgrade a node? That's where a pod disruption budget, or PDB, is your best friend. You create this little object that tells Kubernetes, hey, for this critical app, I need you to always keep at least, say, 80% of the pods running. So if you try to drain a node for maintenance and it would violate that rule, Kubernetes will actually stop and wait. It's your safety net. It's also super important to get how pods shut down. They don't just vanish. First, Kubernetes sends a SIG-term signal. Think of this like a polite tap on the shoulder saying, excuse me, time to wrap it up. This gives your app a grace period to finish any work, close connections, and shut down cleanly. Only if your app ignores that polite request and the timer runs out does Kubernetes send the SIG kill signal.
That's not a tap on the shoulder, that's the bouncer throwing you out.
Okay, we've got secure apps, we've got resilient apps. Now let's make them fast and, not crazy expensive. Let's talk performance and networking. On the exam, this usually comes down to two things: cutting down latency and cutting down data transfer costs.
Let's trace the path of a request from a load balancer. In the default setting, what's called instance mode, the traffic hits a random node in your cluster. Then, a component on that node called QProxy has to figure out where the actual pod is and forward the traffic along. That's an extra network hop. That adds latency. And even worse, if that pod is in a different availability zone, you're now paying for cross-AZ data transfer you didn't need to. Yikes.
Now, let's compare that to the much better way, IP mode. In this mode, the load balancer is way smarter. It knows the exact IP address of the pod it needs to talk to. So traffic goes directly from the load balancer to the pod. No extra hop, no QProxy middleman. The result? Lower latency for your users, and you get to completely eliminate those unnecessary cross-AZ data transfer costs. For the exam, trust me, IP mode is almost always the right answer.
All right, we have covered a ton of ground. Let's take a deep breath and do a quick rapid-fire review. These are the absolute non-negotiable points you need to have locked in your brain for the exam. First up, security. Your pod needs to talk to an AWS service? The answer is ISRA. It's the secure, standard way to grant granular temporary permissions. End of story. Second, resilience. You're doing planned maintenance and can't afford downtime? You need a pod disruption budget. It's like putting up a do not disturb sign on your critical apps that Kubernetes will actually respect. Third, network security. Remember, it's a two-part answer. To control traffic inside your cluster, pod to pod, you use network policies. To control traffic between your pods and other AWS resources, you use security groups for pods. And finally, performance and cost. When you set up a load balancer, make sure its target type is set to IP mode. Just do it. It gets traffic straight to your pod, which means lower latency and a lower AWS bill. It is a total no-brainer. So here's the bottom line. EKS gives you this incredible framework, this powerful toolkit to build apps that are secure, tough, and fast. But it's not a magic wand. As the solution architect, it's your job to know which tool to pick up and how to use it right. The framework is there for you, but the excellence, well, that's in the architecture you design.